Module 5, Objective 3. Understand the role of the margin of error in constructing a confidence interval. As discussed in an earlier lesson, the margin of error is half the length of the confidence interval. We use E to denote the margin of error. The formula for calculating margin of error is on the next slide. In this class, you will not need to know this formula. Our focus will be on interpreting margin of error. Note, to use this formula, we require that the population from which the sample was drawn be normally distributed, or the sample size n has to be greater than or equal to 30. Caution: a confidence interval should include two parts: an interval calculated from the data and is possibly reported as a margin of error, and a confidence level. News reports often leave out the level of confidence, although it is almost always 95%. They also often report the margin of error separately from the statistic being quoted. You need both bits of information to make an informed decision about the report. The narrative of a report might declare that a recent poll shows a majority, 51%, of women favor new laws restricting guns. If the margin of error is 1 percentage point with a confidence level of 95%, we might be comfortable concluding that a majority of women indeed support stricter gun control. We are 95% confident that the true percentage of women who favor stricter gun control laws is between 50% and 52%. If the margin of error is 5 percentage points with a confidence level of 95%, we might not be so sure that a majority of women support stricter gun control. We are 95% confident that the true percentage of women who favor stricter gun control laws is between 46% and 57%. There is a lot of room in that interval to be less than a majority. It would not be a big surprise if another poll claimed a majority of women did not favor strict gun control laws. Now we're back to our pennies. A 90% confidence interval for the mean weight of the 17 pennies from our previous problem is found to be from 2.456 grams to 2.472 grams. Recall the 99% confidence interval found previously was from 2.452 grams to 2.476 grams. Comment on the effect that decreasing the level of confidence has on the margin of error. We are 90% confident that the mean weight of pennies minted after 1982 is between 2.456 and 2.472 grams. The 99% confidence interval found previously was from 2.452 to 2.476. The width of this interval is 0.024. The margin of error is half that interval, or 0.012. The width of the 90% confidence interval is 0.016, which is considerably more narrow than the 0.024. The margin of error is half the interval width, or 0.008. You can see that if we don't need to be as confident, we can narrow the interval that we claim contains the true population mean. The best way to be really sure, more confident you can get the wad in the trash can is to use a bigger can, or in our case, a wider interval. Conversely, if you aren't too worried about missing, you can use a smaller can. Notice that the margin of error decreased from 0.012 to 0.008 when the level of confidence decreased from 99% to 90%. The interval is therefore wider, a bigger can, for the higher level of confidence. Suppose that we obtain a simple random sample of pennies minted after 1982. The 99% confidence interval with n equal 35 is 2.455 to 2.473 grams. Comment on the effect increasing sample size has on the width of the interval. And you'll recall previously we used a sample size of 17. We are 99% confident that the mean weight of pennies minted after 1982 is between 2.45 and 2.473 grams when the sample size is 35. The width of the interval is 0.018. the margin of error is half that, or 0.009. Increasing the sample size from 17 to 35 decreased the margin of error from 0.012 to 0.009. Notice that the margin of error decreased from 0.012 to 0.009 when the sample size increased from 17 to 35. The interval is therefore narrower for the larger sample size. We know larger sample sizes are better. The problem is they're more work-intensive and more expensive. A simple random sample of size n is drawn from a population whose population standard deviation is known to be 3.8. The sample mean is determined to be 59.2. The 90% confidence interval if the sample size n is 45 is 58.268 to 60.132. The 90% confidence interval if the sample size is 55 is 58.357 to 60.043. How does increasing the sample size affect the margin of error E? Stop the video and work this problem before continuing. For part A, our interval is 1.864, so the margin of error is half that, or 0.932. For part B, the margin of error is 0.843. Thus, increasing the sample size decreased the margin of error and made the confidence interval shorter. Part C of this problem says the 98% confidence interval if the sample size is 45 is 57.882 to 60.518. Compare the results to the interval in Part A. How does increasing the level of confidence affect the size of the margin of error E? Stop the video and work this problem before you continue to the next slide. The margin of error in A is 0.932. The margin error for the interval in C is 1.318. Thus, increasing the level of confidence from 90 to 98% caused the margin of error to increase and the interval to widen. A simple random sample of size n is drawn from a population that is normally distributed with population standard deviation known to be 17. The sample mean is found to be 123. Stop the video and answer the following questions before continuing. The 94% confidence interval if the sample size n is 20 is 115.85 to 130.15. The 94% confidence interval if the sample size is 12 is 113.17 to 132.23. How does decreasing the sample size affect the margin of error? So the margin of error in Part A is 7.15. The margin of error for Part B is 9.53. Thus, decreasing the sample size increased the margin of error and made the interval wider. The 85% confidence interval if the sample size is 20 is 117.53 to 128.47. Compare this interval to the one from Part A. How does decreasing the level of confidence affect the size of the margin of error E? The margin of error decreased from 7.15 in A to 5.47 in C. Thus, decreasing the confidence level made the interval get more narrow. Could we have computed the confidence intervals in Part A through C if the population had not been normally distributed? Why? The answer is no, because the sample has to be at least 30 if you don't know that the population is normally distributed. If an analysis of the sample data revealed one outlier greater than the mean, how would this affect the confidence interval? The answer is the interval would be wider and the whole interval would slide to the right toward the outlier because the mean goes in the direction of the outlier. A 90% confidence interval for the number of hours that full-time college students sleep during a weekday is lower bound 7.8 hours and upper bound 8.8 hours, or the interval from 7.8 to 8.8. Which of the following represents a reasonable interpretation of the result? For those that are not reasonable, explain the flaw. Stop the video and work this problem before you continue to the answer on the next slide. Part A, 90% of full-time college students sleep between 7.8 hours and 8.8 hours. This statement is flawed because the statement refers to individual student sleeping time. The confidence interval refers to means or average sleeping time of your samples and not individual sleeping time of students. Part B, we are 90% confident that the mean number of hours of sleep that full-time college students get any day of the week is between 7.8 hours and 8.8 hours. This is flawed because the study doesn't single out a particular day of the week. For all we know, students sleep none on some days and 16 hours on other days, so the average comes out to be between 7.8 and 8.8 hours. Part C, there is a 90% probability that the mean hours of sleep that full-time college students get during a weekday is between 7.8 hours and 8.8 hours. This statement is flawed because it implies the mean varies when the true mean number of hours of sleep college students get is a fixed value. We just don't know what it is because we can't possibly survey every single full-time college student about their sleep habits. D is the correct statement. We are 90% confident that the mean hours of sleep that full-time college students get during a weekday is between 7.8 hours and 8.8 hours. E, what could be done to increase the precision of, narrow, the confidence interval? You could either increase the sample size or lower the confidence level. And remember, the third thing that affects the margin of error was the standard deviation of the population, and we don't have much control over that. According to Nielsen Net Ratings, the mean amount of time spent on MySpace.com per user per month in July 2007 was 171.0 minutes. A 95% confidence interval for the mean amount of time spent on MySpace.com monthly has a lower bound of 151.4 minutes and an upper bound of 190.6 minutes, or the interval from 151.4 to 190.6. What does this mean? And I need to update my slides because some of you may not know that MySpace was the precursor to Facebook. Stop the video and think of the answer before you continue. Based on the sample, we are 95% confident that the population mean time spent per month per user on MySpace.com is between 151.4 minutes and 190.6 minutes. We are confident that the sample drawn is one of those 95% of the same sample size that would produce an interval containing the true mean. What's wrong with this? The mean age of the 42 presidents of the United States on the day of inauguration is 54.8 years with a standard deviation of 6.2 years. A researcher constructed a 95% confidence interval for the mean age of presidents on inauguration day. He wrote that he was 95% confident that the mean age of the president on inauguration day is between 53.0 and 56.7 years of age. What is wrong with the researcher's analysis? He doesn't need to have a confidence interval. Confidence intervals are for when we have to use samples to estimate a population parameter that we don't know. He had the whole population of U.S. presidents. The mean he found is the true population mean. It's not an estimate. Now complete Module 5, Part 3, Assessment of Learning. The password is margin in all lowercase.